Hey everyone, so today we're going to talk about graphing polynomial functions. This is kind of the last step, the last topic for polynomial functions that we're going to talk about. We have learned all kinds of things about polynomial functions, how to factor them, how to find their zeros, and all of this information is helpful to us when we want to actually graph the polynomial functions. So today our objective is we're going to graph polynomial functions using the zeros, the y-intercept, and other points. And then we're going to approximate an irrational zero of a polynomial using the graph and successful approximation. So let's first talk about the general shape of a polynomial function. So we know that the general shape of a linear function is a line. And we know that the general shape of a quadratic function is a parabola. So now we're going to talk about the general shape of a polynomial function. Well, there are different degrees of polynomial functions. The first degree is when your degree is 1. So if you're looking at your highest term, this x has the invisible 1 on it, right? So it has a degree of 1. A second degree is going to have x squared, so 2. Third degree will have x cubed. Fourth degree would have x to the fourth, and so on. So why is this important? Well, it's important because it's related to the number of turns the graph takes, okay? The degree of your polynomial is 1 more than the number of turns in the graph. So for example, if you have x to the third power, and you have a third degree polynomial, that means that your graph is going to turn twice. All right, let's talk about what we can find out if the degree is even or odd. This also tells us characteristics of the polynomial function when we graph it. So functions that are in even degree, so degree 2, 4, 6, 8, anything that's an even degree, the left and right tails go in the same direction. So the left tail and the right tail, and that's at the very end of your function, they're both going to go in the same direction, either up or down. So if you have a leading coefficient of negative, they're going to go down. If your leading coefficient is positive, they're both going to go up. Now, if you have an odd degree function, so we're talking about a third degree, a fifth degree, a seventh degree, or even a first degree, the left and right tails go in opposite directions. So if your left tail is going downward, your right tail is going to be going upwards. We keep switching pages. There we go. On the graph, if we want to find the zeros, instead of factoring the function, all we had to do is look where the curve crosses the x-axis. That is where your zeros are. Wherever the curve crosses the x-axis, that's going to be x equals whatever your number is, that is the zero of that function. The only catches is that because you're crossing the x-axis, your zeros must be real numbers. They won't be imaginary numbers. Okay, so for example, if we want to graph the equation, if we want to find the zeros of x cubed plus 2x squared minus 5x minus 6 equals 0, the first thing we would do is we would graph that equation. So you're going to take your calculator, you're going to go to y equals, and you're going to put into your calculator x cubed plus 2x squared minus 5x minus 6. So that's going to go into y equals. Make sure that if you're using a TI-83, that you put parentheses around each term. So x cubed should be in a set of parentheses, plus 2x squared should be in a set of parentheses, minus 5x should be in parentheses, minus 6 equals 0. You don't have to put the equals 0 because remember, we're letting the y equal 0. So all we're plugging into the calculator is this first part. Remember, that goes into your y equals in your graphing calculator. So if you hit graph, you should get a curve. Just a couple of things. Let's talk about the degree. So we know that the degree of this polynomial is 3, right? Which is a odd degree. So since it's an odd degree, your left tail and your right tail should be going in different directions. So check your graph, and it looks like the left tail would be going down and the right tail would be going upwards, right? Also, we know that since it's a degree of 3, that it should have 2 turns. So when they're talking about turns, they're talking about once the graph has started, how many times does it change direction? So if your graph is starting up, and when it turns and starts going to go down, that's the first turn. And then once it starts going down, it's going to turn again and go back up, and that's your second turn. So there are 2 turns because it is a third degree. So now that I kind of explained to you the degrees, what we want to do now is we want to find where the graph crosses the x-axis, because that's going to tell us the zeros of this function. So looks like we have x equals -1, x equals -3, and x equals 2 on the graph, right? Now, we found the zeros, but let's say it wants to know what the factors are. Remember, factors are x minus a number times x minus a number times x minus a number. Those are the factors. We get the factors from the zero. So if we know that we have a zero, x equals some number, then the factor is going to be x minus that number. So just so you know, we can get factors from our zeros. All right, that's all that I needed to talk to you about. We're going to practice graphing in class the next time I see you, and we'll have lots of fun. Thank you.